Okay, welcome back, Matadors. We're now getting into the latter part of Chapter 2 on rotations for this next geometric transformation that we're going to be covering. I'm going to split this lesson into two parts, so there'll be two YouTube videos for Chapter 2, Lesson 4. The first video is what we're going to be covering right now, and that's going to basically consist of an overview of what a rotation is, and some generic examples of some rotations being performed. And then the second video will consist of actual examples of rotating shapes. So here we go. This is Chapter 2, Lesson 4. The essential question: what are the three basic ways to improve an object in a plane? Or to move, an object in a plane. As of right now, we should know the following three, which you can see here in the video in this section here. The three ways. So we learned translations, where you slide a shape, right? And the y coordinate, it would slide either up or down. So you would either add going up or subtract going down to find the new coordinate of the y. And the same thing goes for the x. The x is moving either left or right. And if you're adding to the x, it's going to the right. If you're subtracting from the x, it's going to the left. Reflection. So that was the mirror image example. The key word was flip. So that means you're flipping the opposite coordinate to either negative or it's a positive version of itself, depending on which axis you're performing the reflection over. So for example, if I'm reflecting over the y, then I flip the x to its opposite number. If I'm reflecting over the x-axis, then I'm going to want to flip the y coordinate to its opposite number. And rotation, the key word, the word of the day is going to be turn. Okay, turn. So we're going to be making turns for various shapes in this set of notes here. A rotation happens when a figure is rotated about a point. So it's going to be rotated about a point, and that point is called the center of rotation. The number of degrees a figure rotates is called the angle of rotation. Okay, so you have a center of rotation, which could be the actual origin of a coordinate plane or a point that is on the actual shape itself. Okay, and the angle of rotation is how many degrees you're going to rotate that shape. And we'll get into that a little bit later. So there's two directions you can move. Clockwise, which is probably the way that we're most comfortable with because we're used to looking at clocks and they rotate in a clockwise direction. However, in the math world, counterclockwise is the standard of rotation. Okay, unless indicated otherwise. So let's first look at this clockwise example here. Here we have a right trapezoid that we're going to rotate, and it's rotating clockwise, right? As you can see, it's rotating clockwise in this direction here. Now, that little pink dot here is called the center of rotation. So it's basically, you have kind of this string tied from the center of rotation to the shape, and you're rotating that string or that shape counterclockwise. Okay, now another thing I want to address is this symbol here. If you recall, that little red box is not where you rent videos. It means that there's a 90-degree relationship between these two lines here. So this example consists of a right trapezoid being rotated 90 degrees clockwise, 90 degrees clockwise. Okay, 90 degrees is kind of the way I'm going to ask you to think of rotations is in 90 degrees. And 90 degrees is kind of like an L shape. Okay, it's kind of like an L shape. So that's a 90-degree clockwise rotation. Let's look at the counterclockwise rotation. So now we're going to be going in counterclockwise. So it's same shape, a right trapezoid. But now if you notice, it's going in the opposite direction. This is counterclockwise. This is a counterclockwise rotation. Here's the center of rotation. Here's the string I want you to imagine is being rotated down 90 degrees. Here's the 90-degree box. So it's showing you that this shape here, this right trapezoid, is being rotated 90 degrees counterclockwise. Now usually you're not going to be given the choice or the word counterclockwise. It would just say 90-degree rotation. That means you're rotating the shape counterclockwise. That's the standard. This is the standard in math, okay, unless indicated otherwise. Okay, so again, we have the actual rotation of the shape. We have the strings I want you to visualize when you're performing a rotation. You have the center of rotation to take into consideration, and I want you to also always relate it back to how many 90 degrees am I rotating a shape. So use the 90-degree increment to kind of help you navigate through making the rotations. Moving on. So here's a circle. We all know a full circle is 360 degrees, right? All the way around a full circle is 360 degrees. We know that. Now let's look first. We're going to look at the clockwise rotation. So I want to show you a clockwise 90-degree clockwise rotation, and we're going to use this as our starting point, okay? And we're going to use this green mark here as our center of rotation, right? Our center of rotation. So this green mark here is going to be the center of rotation. Okay, that's what we're going to be using. So now here's an example of a 90-degree clockwise rotation. So we're going to start here. We're going to use this center of rotation. So it's kind of like we have a string attached here. And now we're just going to rotate it 90 degrees so it winds up over here. Okay, so that would be a 90-degree rotation. So from here to here is a 90-degree clockwise rotation. Okay, so now let's go ahead. We're going to next go over a 180-degree rotation. So we're going to take this starting point here. We're going to connect it to our center of rotation, but now we're going to rotate it 180 degrees clockwise. So this is 90 to here. We need to do another 90 in the same direction, so that will put us over here. That's where we would end up in a 180-degree clockwise rotation. So now let's do a 270-degree clockwise rotation. So again, starting here, we're going to connect it to our center of rotation, but now we're going to rotate it 270 degrees clockwise. So again, we know this is right here, that's 90. We know this is our second 90, that's 180. And this would be our third 90, or 270. So that's rotating that starting point 3/4 of the way around the circle till you end up in this point here. And we know the 360, it's going all the way around back to where we started. So those were a brief overview of clockwise rotations. Again, notice that they're in increments of 90, and 90 is like a quarter turn, a quarter of the circle. Okay, so now let's take a look at the counterclockwise rotations. What is that going to look like? So let's do a 90-degree counterclockwise. So we're going to start here. We're going to connect it to an imaginary line to the center of rotation, and we're going to go counterclockwise 90 degrees. So that's 1/4 turn to this point here. That's what a 90-degree counterclockwise rotation would look like. Okay, now let's do a 180. So that's going to be 2 90s, right? This is like 2 90s. So now I take, let me redraw this. I take my starting point here. I have my imaginary line connected to my center of rotation. I'm going to go counterclockwise. Here's my first quarter turn, that's 90. But now we want to go to 180, so I do my second 90, and that's where I would end up at, 180 degrees. So basically on the opposite end of the circle, counterclockwise. Okay, let's go over a couple more. So now we're going to do the 270. This is what a 270 counterclockwise rotation would look like. Start at the starting point, connect it to the center of rotation, and now 270 degrees is 390. So this is my first 90, this is my second 90, and this is my third 90. So that's where I would end up at after making a 270 degree counterclockwise rotation. Lastly, 360, those are the easy ones, right? So here's our starting point, connected to the center of rotation, all the way around the circle, 360 degrees back to where we started. Okay, so those are the basic types of rotations, both clockwise and counterclockwise, given the visual of a circle. What I want you to remember is the 90s, okay? I'm sorry, the 90s. Not the decade, the 90s. When I grew up, flat tops were cool. I'm talking about 90 degrees as in quarter turns of circles. So how many 90s are you going to make in your turn? That will give you a hint as to where your shape will end up after you're done with the rotations.